So yesterday we were trying to do this, but we could not complete it because of our time. We will do this and maybe some other questions that I found interesting because I tried to solve some of them myself. So we might be doing one more, if not two. I haven't completed this, but it should work. So we can do number 4 after this together as well. After which I want us to do some practice on inflection. I wanted to go into the graph of function and their derivative, first and second derivative initially, but I thought, okay, we need to give ourselves time to practice this, digest this idea instead of rushing. So worst case scenario, I will do that after L'Hopital's rule. The idea is for me to do this today and inflection, and towards the end introduce the graph towards the end of the class, but we don't have that kind of time. So I will go straight to L'Hopital's rule next lesson, so that can reflect in your test, because I need that to reflect in your test. If towards the end of the class I have time to introduce the graph, I will include it. If I don't have time to introduce it, or I feel that everybody didn't get it quite well, I will remove that and we can review it next week. Then it will be in a later test. Because I have 1 or 2 past questions on that graphical aspect. So the point is, if you are given f of x, you might be asked to sketch the graph of f of x based on all these interesting facts we have discovered. Understand? So I need us to understand that, but I don't want to rush again too much, even though we are working against the clock. So f of x, I think we completed this table yesterday. At b, it is negative, yes? At c, it is positive. At d, it is positive. And at e, it is 0. Yes? Then the derivative, negative derivative, yeah? What about here?
0.
0, being a turning point. What about here?
Positive.
Positive. And here?
0.
And here?
Negative.
Negative. Okay? Second derivative is the rate of change of the first derivative. It's coming from negative at A. It's coming from negative. Okay, this is a negative. It's reducing. Is that not? Is it reducing? No, it's increasing actually. Can you see? It's increasing, it's increasing, it's increasing because it's going to become positive here. Are you getting my point? So, at B, still increasing. Because we're looking at it as time goes on. There is no information if this was coming from negativity. We don't have more information. And I also assume this is a cubic function. Okay? Such that it's probably, that arrow tells you it's going up like that. So it's a negative gradient that is going to end up becoming positive here. So it's an increasing, the rate of change is increasing. I'll show you that some demo from yesterday again. Do you understand? So if you draw a tangent somewhere here, you might be getting negative 1.5. The next tangent might give you negative 1. Then negative 0.5, you see? So as you move closer, you are moving closer to a tangent that gives you 0. That's what we mean by increasing. Okay? At B also, what is the rate at which it changes? It's still positive. Okay? At C, that is when it is 0. Because this is where the shape changes. It was concave upward. From here, it becomes concave downward. So we can't discuss anything here. You can't say it is increasing or decreasing. A new journey begins here. And another increasing begins. Are you getting my point? So, this is 0. Then at D, of course, it's going to be positive. Alright? Positive here. Any time from here is positive gradient. But the positive gradient will continue to reduce until it gets to 0. So there's a negative change there. Okay? And at E, it continues to become smaller. So you still have your negative. Okay? Then the next question says, describe the turning point. There's a slight difference between turning point and stationary point. We're going to talk about that very soon in stationary point. Every stationary point is not necessarily a turning point, but every turning point is a stationary point. We'll talk about that in a bit. Describe the turning point. So when we're talking about turning point, we're talking about maximum, minimum. But when we're talking about stationary point, it includes the point of inflection. Okay? So, at turning points, we say describe the turning point. These are the two turning points, right? So you just say, oh, B is a turning point, and it is local what? Minimum point. There's another one, which is D, which is what? A local maximum point. Then question C. At what point does the shape of the function changes? At what point is that? At C. That is where your concave upward changes mind and say, okay, now I want to be concave downward. Okay? So this is where that changes occur. We'll discuss the importance of that point C very soon. Okay? Now, question 2. The first thing is to find the first two derivatives. From here, 3x squared plus 6x minus 5. Is it okay to write that? Is it okay to write that? Great. Second derivative, 6x plus 6. Oh, this is factorizable. It might come in handy. But that is not factorizable. I've tried to. Say, no, don't factorize me. How do you know something is factorizable? Check if your b squared minus 4ac gives you a perfect square. Okay? My b squared clearly is 36. Minus 4ac is plus 60. 96, last time I checked, is not a perfect square. So that is not factorizable. Let's check here. A is 0, right? So b squared minus 4ac is simply b squared, which is 6 squared. And that's 36. So yes, this is factorizable. I use quadratic for it, even though it is linear. Understand? So if b squared minus 4ac is not a perfect square, then it's not factorizable. So we stop here. Draw the sign diagram of the second derivative. Because this is factorizable, you could see that something happened at minus 1. Right? If you look further, at say 0, this is positive. At negative 2, this is negative. Okay? That's the sign diagram. So, what does that mean? Remember, the second derivative is the one that tells you there's a change. Look at this picture. At this point, you have positive because the gradient is increasing. Right? At this point, you have 0. That's where there's a change in the shape. Okay, at C, there's a change in the shape. At C, this is your point, C, where there's a change in the shape. Remember, f prime of x is the rate. This is the rate of change of what? The first derivative. So your first derivative was negative. Suddenly, it changes to positive. So this is where the shape of the curve changes. All right? The question just says to draw the sign diagram. It doesn't say any other thing. So additional information is that, oh, this implies that there exists a change. I don't know if we need that or not, in the shape of the curve f of x at x equals to negative 1. Clearly, that is the meaning. All right? Questions? The last two questions says, now, oh, you see that would be helpful now. State the interval on which the function is concave up. Concave up. Concave up is, so the reason for this, even though we have the shape, minus 1, this is really minus 2. So minus 1 is here, right? So it means this is where the change occurs. Can you see that? Okay, concave up is here. So that's from -1 and above. Concave down is -1 and below, right? So you just say, can just write f of x is concave up. Let's say up or upward, up. When, what happens when x is greater than or equal to -1? Understand? And f of x is concave down when x is less than or equal to -1. Understood? So your second derivative tells you where the shape of the curve change from up to down. You will notice this especially in a cubic function and above. Quadratic doesn't have that kind of thing. This guy is so consistent. See that it is positive or negative. It doesn't change his mind. Okay? It's not like when you go to the supermarket and you don't make up your mind, should I buy this or should I buy this? You know, I know you always do that, right? Do you understand? Any questions? So I noticed this was a bit confusing because I was rushing the last aspect, so I thought, okay, we need to do this again. Now, we're going to take question 4 together. Has anyone tried it? Question 4. So we should do it together. Again, this is -2. So we've discovered -1 ourselves. So this is the point where it changes. Let's do question 4 together. Consider the function f of x is ln 2x minus 1 minus 3. Please let's do this together. The first question says find the x-intercept, right? X-intercept is when what happens? When y is equal to 0. So which means when f of x is equal to 0, right? X-intercept means when f of x is equal to 0. So which means when, I was going to write Lillian. When that happens, right? So we get that. I hope everybody is working with us here. So that when we have questions, you can speak. All right? So what happens now? 2x minus 1 will be exponential 3. Yes? Which means 2x is exponential 3 plus 1. Then x is exponential 3 plus 1 over 2. Okay? So that's your x-intercept. So x-intercept is basically x is equal to this. Or you could say x is equal to this, y is equal to 0. It doesn't matter. The next question. B. Can f of 0 be found? Anyone? Can f of 0 be found? Why?
Because if you put x is equal to 0, then be -1.
It will be negative. So it is undefined. On the real line anyways. You can find logarithm of negative is as a complex number. How do you know that? You should give it that as some of the exam questions someday. And say find the log of minus something. Have anybody tried to investigate that? I once played with it, it's so crazy. But it's interesting. I'll give you a clue. I need you to think about it. Yeah. Let's try that. Let's just calculate or put it in complex mode. Let's see if we can find log base, let's say base 5 of minus, should I use 5? Let's use a different number. Minus 7. Try this in the calculator, but make sure you're in complex mode. It should work.
Turn on complex mode.
Shift menu, and then scroll down. It should say real and one bar. Change it to. Oh, that's cool.
Did it work?
Yeah.
You got a complex number?
You go menu.
So you scroll down. Complex mode. Right now it's in real. You can change it to.
So what do you get?
Wait, so it's not this?
Huh?
It's not the
Venom, what do you get?
Oh.
1.5. 1.2.
1 point. Just give me 2 decimal places for each part.
Yeah, 1.21
1.21.
plus 1.95i.
No.
Interesting, isn't it? Can anybody think of how we can get this? I know it's outside this, but what if you have some, it might even be some interview question to just see how you reason someday. You understand? How do you think we can get this? Let's try it together. It's a note thing I've done in the past. I surely remember. But let's hear your view. Logarithm of this. So definitely this is a complex number. It doesn't belong to R. That is why we always get, logarithm must be defined when x is greater than 0, because we always deal with real valued function. It doesn't mean when we have a complex valued function, we can't do it. And I'm sure we have seen that, when we introduce complex number in Form 5. Yes, you wanted to say something.
You have to do log base 5 and then 7.
Log base 5, yes.
And then 7 plus log base 5 negative 1.
7.
And then like you do you split it up into 2?
The second one will be
Negative 1.
good. That's one nice step. What next?
You set the log base 5 negative 1 to equal to something.
Okay, let's try that. Set this to be something like A, okay?
Then like do 5 to
5 to the power of A because negative 1.
and do something with like the m
Speak louder, please.
Wait. I mean,
Sorry, I know I'm wasting time, but I want us to gain something from this also.
you could do 5.
Say that again?
5 equals 2. No.
Oh, wait. You could do 5 equals roots a negative 1.
Root A negative. Root A. But remember, we are looking for A. Because once you can find out what A is, then we are good. So why do you want to find root A when A is your unknown?
Negative 1 is
Square root of
something
negative
high.
1, you can't say. Because if the root is odd, you're going to get a complex number. If the root is even, you get a complex number. Odd will just be minus 1. At least one of them, depending on how many roots you're looking for.
Can you change negative 1 to I squared?
I'm going to do that. Everybody agree with that, right? Nice try. The easiest way, just go to natural logarithm. That's the easiest way. This looks okay, right? So this is probably the major problem. So we may just leave this, or you change everything to natural logarithm from the beginning. Or you just leave this one. So if I change everything to natural log from the beginning, agree? So I can say A divided by ln 5, where my A is natural log of, no, actually, this could be, understand? Okay? So I could call this where such that my A is the natural log of 1. Understand? Clearly, exponential A is negative 1. Right? But we know Euler's identity. Remember this? So, if this is that and that is that, clearly, okay? Somebody check in the calculator. Ln minus 1.
Yes.
You get what? Pi I. Can you see that? So now that we have that, it means everything log 5 base 7 is simply what? 7 plus pi I, everything over 5. You can simplify any other way. So if I want to break it into 2, then 7 over then 5, then no. This is 1 over then 5 pi I, right? This I can merge into logarithm, yes? And this could just be, this is logarithm to base e, so it could be pi I logarithm to base 5, is it? Yes, of e. If I flip, initially this one is 1 over log to base e of 5. So if I flip it, it becomes this. And this comes here. So check, what is log 7 base 5? Is it 1.21? Is it 1.21?
Yes.
Yes, okay. So let's check. What is pi times log e base 5? Does it correspond to 1.95? No, you remove the I, just check the others. Pi log e base 5. Is it? So that's how the calculator gave you that. It's an interesting thing to think about. So yes, logarithmic function is not defined. Logarithmic function of a negative is not defined in the real sense. But if you look beyond the real number, you go to the complex, you'll be fine. I would not expect this, but you know, maybe you're working on problem 3, which requires a lot of thinking. This kind of way of thinking will come in handy. So just a combination of what you know and the Euler's identity, which you already know also from Form 5. Understand? So why did I bring that rubbish up? Can f of 0 be found? He said no. Because when you have 0, you have a negative. And that is why you cannot find f of 0. So we write as follows. F of 0 cannot be found since f of 0 is going to be ln minus 1 minus 3. Right? Which is not defined. Which is not defined in R. Only in R. You can see already, that is defined in C. As a matter of fact, that minus 1 itself is what? Is this. Okay? In R, so it's very important. And because of course we are dealing with a real value function, our graph is also a Cartesian coordinate in R, so of course it's not defined. So the next question is, what is the significance of this result? So what's that? What is the significance of that result? Say that again? Yeah, I know. We just said it does not, it's
What
not.
does it mean?
Yeah, so what does that mean? So what does that mean in the real? There is no y-intercept. Thank you. This means there exists no y-intercept. So when you are sketching your curve, don't expect it to cross anywhere on y as the point. Okay? The next is find the domain of f. Yes, I think that should be easy. What will be the domain of f? When will it be defined? Yes. Find the domain of f. What is the first thing you should think about?
Greater than 0.
When what is greater than? You just say when greater than 0.
When x is greater than
Are you sure?
When x is greater than 0 plus r.
How do you get that? What is what you think about first? Your first thinking, your first thoughts is what I'm interested in. How would you begin I know you are selling me the answer, especially you just told me the right answer now. But how did you get there? Somebody in this class might not know how you got to that point. So what is the first thing you look out for?
The left side of the natural log.
Just read it, please.
2x minus 1.
Say that again.
2x minus 1
Uh-huh.
is square root of
2x minus 1 must be greater than 0. So it is only defined when 2x minus 1 is greater than 0. Because otherwise, when it is less than 0, you get something else. Hello? Hi. So f is defined for 2x minus 1 greater than 0, which is where you got your this. Right? So the domain now. The domain of f is simply half is not included. That's why I use that interval. Up to where? Does it have any upper limit?
No.
No. So what do we say?
Infinity.
Infinity. Okay? Another way to write this, you can use your set builder notation. The domain of f is set of x such that x is more than half. That's it. Your choice how you write it, as long as it communicates the idea clearly. The next part of the question, D. Find the gradient of the tangent to this curve at x is equal to 1. What do we do first, Karen? Find dy here. So, if you differentiate, because it's a natural log function, we flip it, then we multiply by the derivative, which is 2. Derivative of that is 0, so basically it is 2x minus 1. And the derivative at x is equal to 1. That's what it means, right? At x is equal to 1. That is 2. Agree? So it means that x is equal to 1, the gradient is positive. So our tangent goes like that. Right? So it's an increasing function, sort of, at that point. Right? Alright. What else do we know? E. Find the second derivative. So from your first derivative, which is 2x minus 1 negative 1, right? Find my second derivative. You see, I had to quote my first derivative clearly, because I don't have that form here. I don't need it here, so there's no point to write it here. But I need it here, you just take your time, write it one step. This will be negative 2x minus 1 negative 2 times 2. Understand? So this will be negative 4, 2x minus 1 squared. That's the second derivative. Hence, explain why f of x is concave down for all x. Anyone? Why is f of x going to be concave down for all values? It's always negative. The second derivative is always negative. Look here. When your second derivative is negative, it means your point, your graph, is moving towards concave down. Negative means the gradient keeps reducing. Okay? So let's look at this. When is our gradient reducing? This is when the gradient is increasing. Okay? Because it's going to become positive. So for it to become positive here, coming from negative, that's an increase. But from positive going to negative, that's a decrease. Okay? So this is where your second derivative is negative. And for any value of x you put in there, your second derivative will always be negative, because this will always absorb any negativity. And so the negative here will always dominate. Okay? So since for all x in the domain, f of x second derivative is always negative, it implies that f of x is always concave. Did I say downward? Did the question say downward? Yeah, down, concave down. Something like that. You just explain in your words, of course. And the last but not the least, graph the function showing all the features you have found. I'll take a picture of this. But maybe we can do it in that tiny little space. So we have X-intercept. Can somebody put this in the calculator? I think I got 10.5. You don't need to write 10.5 first, but because we need to identify what is that point, right? So you need to figure that out. So draw your X and Y